Now we have to find out the stress and elongation produced in a circular bar of length L and diameter D. Now consider an elementary strip of ABCD as shown in the figure of thickness dy and at a distance y from EF. We'll measure the y from the bottom end. So here it will be y is equal to 0 and top end will be y is equal to L. Now this is fixed at this particular end. Small w is known as the weight density, that is weight per unit volume. So this is nothing but w upon v. So weight or force, you can say that. So weight is in Newton or force is in Newton and volume is in meter cube. So w upon v. Now w will be equal to small w into v. Now volume is area into length or area into height. So it is pi by 4 d square into y. Now stress is equal to force upon area. So W, you can substitute the value small w into pi by 4 d square into y, and area of the bar is pi by 4 d square. So we can cancel out this pi by 4 d square from the numerator as well as from the denominator, and so that will get sigma is equal to small w into y. So this is the expression for sigma. Now stress is directly proportional to strain within elastic limit, and constant of proportionality is known as modulus of elasticity. Small e is a linear strain, that is equal to delta L upon L. So sigma cross multiplied by this L divided by E will give the value of this delta L. So we can say that this L is now replaced by small elementary thickness of the ABCD and divided by E, and the value of sigma also we can substitute in terms of y, so that we can easily integrate this particular equation. So sigma is nothing but w into y divided by E into dy. So this is w upon E y dy, and integrate it from y is equal to 0 starting point up to the end point, that is y is equal to L, so that we'll get the total elongation of this particular bar. Now integration of y is y square by 2. Take these two outside so that we can apply the limits. Lower limit is 0, upper limit is L. So w upon T e y square from 0 to L. In place of y, substitute the upper limit, that is L, and in place of y, substitute the lower limit, that is 0. So it is w square upon 2e. That is the deformation of this particular bar in mm.